Hey, welcome back. It's True again with another phytech development video. Today we're going to be looking at the Flutter graphics stack on the phyCORE-i.MX 8M+. Let's get into it. First thing we're going to need is we're going to need that Ubuntu 20.04 Linux host environment. We're going to navigate to the BSP directory we've set up in the videos past. Go ahead and source that environment. And now we're going to navigate back to the sources directory, and we're going to clone our Flutter meta layer. Going to make sure to grab the scarf gap version of Meta Flutter. And once we've done that, we're going to navigate back to the build directory. And we're going to enable both Meta Flutter and the Meta Flutter apps sub-meta layer. So this is the path to Meta Flutter that we just cloned. This bitbake layer's add layer path will enable that layer in our build tree. And then we'll have to run that again on that sub repo. So there's like a repo nested within Meta Flutter that'll give us access to a bunch of pre-developed apps that we can use to evaluate the stack itself. Now that we have those enabled, there's a couple, there's one key recipe we'll have to enable in our image. So go down here into the conf/local comp, add an image install append variable. Oops. And the key recipe we really need is the Flutter Wayland client. Now this will allow Flutter to access the Wayland desktop that we have running on our development kit. And so this is a key recipe we'll need to enable Flutter in general. This alone is sort of the connector between your application and the Weston compositor, Weston desktop environment. We'll actually need a Flutter application itself as well. This is not an application on loan. And so we can grab that. There's a number of examples available in Meta Flutter. We're going to grab this Flutter samples material 3 demo. I found that one showcased a lot of nice features, widgets, and then we'll go ahead and rebuild our phytech QC6 demo image. This is the default one supported by phytech on our development kits. We're just going to include Flutter support into this image, so it'll have Qt support. It'll also have Flutter added on top. Once that wraps up, we can find our generated images here in the deploy directory. Looks like we have our phytech QC6 demo image. Recall that we added the Flutter dependencies there. So we're just going to have to flash this to an SD card and boot it up. There we go. Now that we've had the SD card flash, let's go ahead and boot that up on the hardware. So in this case here, because it's the default image, we'll first have to modify Weston. These are similar steps to what we've seen in other videos of this series. Just turn off HDMI, which is on by default, and we'll just enable LVDS. And then we'll restart the Weston systemd service. Oh. Fantastic. And then the Qt demo startup. We'll go ahead and stop that as well. There we go. And now how do we go ahead and evaluate that Flutter support we added? Here is a handy command I have in my guide. We are declaring this variable LD library path. This is going to point the Flutter client to the appropriate Wayland client that we added. So Flutter client, I believe, is the generic. It needs to point to a specific compositor, a compositor-specific driver, essentially. And so I'll grab that here. And then the bundle points to the application itself, which we can provide this path to the Flutter samples material 3 demo we added. Go ahead and hit enter on that. And here we are. The materials 3 demo showcases a number of widgets and buttons, pre-integrated styles that we have available in our GUI. And so we could go ahead and explore the source code for that. Flutter is open source provided by Google, so we're free to explore. We're going to go ahead and start looking at custom GUI development now. For our custom Flutter GUI development, we're going to need to create a new environment here. We don't want to overlap things with the BSP, so I recommend creating a new terminal session, navigating out of the BSP, and now this is separate from the BSP environment. We want to keep that up in a tab. This is going to be handy for us later. In this case here, we have a fresh environment, new terminal session. We're going to go ahead and first upgrade our CMake. Flutter's workspace automation, that is like the host side development package that we can use to create our GUIs. It's going to require CMake version 3.19 and Ubuntu 20.04, which is the one that phytech used to validate the PD24.1.0 BSP. Ubuntu 20.04 is only going to have version 3.16 available, so we'll have to go ahead and upgrade our CMake using a tarball from CMake directly, cmake.org. We're just going to navigate into our downloads directory, download that with this wget command. Now that we have it downloaded, we can just go ahead and unpack that tarball. We're going to navigate into the bin directory in there, and we can see here CMake is actually pre-compiled for us in this particular tarball, so we don't have to build it, we just have to export it, the path to it, and add it to our path. And now we can go back to our home directory and verify that the CMake version is 3.19 that we just installed. We're going to also need to grab a number of Flutter specific dependencies. So these are separate dependencies from the BSP, and this list will be provided in the guide for you. Okay, so now that we're ready with our CMake dependency, or version dependency there, we can go ahead and grab the Workspace Automation Project version 2.0. This is going to allow us to develop our GUIs here on the host. Once that's closed, we can navigate into our Workspace Automation Project, and I want to point out this configs directory. This is going to contain a number of JSON files, many of which I haven't dove into, but there's a few key ones, some real important ones that we can go ahead and copy over. What I found is if we set up the Workspace Automation here with the default config, it is massive. There's a lot of examples enabled. It'll support multiple target architectures and operating systems and even web applications. All that stuff here is a little out of scope for this video, and we want to just focus on running Flutter graphical applications on the phyCORE-i.MX 8M+. So what we're going to do is we're going to first create a configs custom directory. You can name this however you want, and we're going to copy a few of the provided configs over to that. So the first one would be the Flutter JSON, Flutter engine JSON. Flutter engine is going to be that runtime engine that allows this to run. Then the config/global. This is going to choose the Flutter SDK version itself. We're going to take a look at that in a bit. And then the configs repos. So the repos JSON here is going to be for the examples that are pre-developed for us that we can study the code for. Let's go ahead and first copy all these configs over to our configs custom directory, and then let's take a look at some of those. The Flutter engine, there's not too much exciting going on there. I wouldn't recommend touching that one, but unless you know what you're doing. But the globals one, this one is key. Note here version 2.0 of the Flutter Workspace Automation project. It's tagged version 2.0 or branched or whatever, I can't remember. But it seems that it's not a firm like release tag or branch. It has changes being pushed to it all the time, and even in one day I've noticed that this version here has changed. My recommendation would be to set up the workspace with 3.24.4, because that is the version that PD24.1.0, the phytech BSP, supports. And so we're going to want our workspace automation to be in line with the actual Flutter version on the target. So here, ensure that 3.24.4 is set. This number apparently can change at any time, so just be aware. We're also going to go into config customs repos.json, and here we're going to pare down the total scope of the workspace automation such that we're focusing on just this example project repository. There's many example project repositories in here. You could set up your own as well. We're going to go ahead and pare down our config here to just include that samples repo, like so. There we go. And here we're going to add rev and then the commit of this samples.git repository that we want. The one that I verified here is provided in the guide. It's going to be this commit. Looks like I added a second quote on accident. And I see it. So we're just missing a comma. Go ahead and add that comma back. And now, cross your fingers, Flutter Workspace should install itself. And there we have it. So once we see the workspace, the Flutter Workspace Python script complete, we should see some Flutter Doctor output that should confirm that we are good to go to develop on our Linux desktop here, our host machine. You're going to get some warnings here on the Flutter channel or version. These are just calling out the fact that we're not on a latest, which is fine. We want this to be in line with what our BSP version, PD24.1.0 provided us in Yocto ScarCap, and that is this exact version. So we're good there. And then we also want to make sure that our samples repo that provides the materials3 demo, that clones successfully. So everything's looking good here. Now we can go ahead and source the setup environment, like so. And when we do that, it'll run Flutter Doctor as well. By sourcing the setup environment, we have access to the Flutter command line tool directly. So we go ahead and get some helpful output on how to use that. And a nice handy tool here is Flutter Doctor, and that's what happened automatically above. How do we go ahead and try out the samples demo that we set up here in the workspace? Well, we can navigate into the app directory, and then there'll be a directory for the project, the repo that we grabbed, and then this samples directory actually provides a number of additional demos. We want the materials 3, which should be right here. So we'll go into materials 3, and now we can just run Flutter run. This will automatically build and then run. And there we have it. So we have our materials 3 demo. It's exactly the same as what we had on the LVDS touch display on the phyCORE-i.MX item plus development kit. We're going to go ahead and close that, and we're going to look at creating our own custom GUI. How do we do that? Navigate back a few directories, back to app, and here we can use that Flutter tool again. Flutter create we can use. We're going to give it the name for our project. Here we're just going to call it Flutter custom. The -T is the template, so this is going to be using the application template to create Flutter custom. Go ahead and hit enter using that. Now what does that look like? We go ahead and navigate into Flutter custom and run, do Flutter run again. And there we go. Here is our Flutter custom demo. This is using the application template. This is a very simple demo. It'll just increment the counter here depending on how many times you press your button. That's great. Let's try running this on our hardware. What does that process look like? We are going to need to first create a license for our project. I believe this comes from Flutter directly. We're going to have a license, otherwise when we use a tool that'll come in later on, it'll throw some errors at us if we don't have this. So let's go ahead and create a license. And this is going to be a BSD3 clause license. And we're going to go ahead and grab the structure for that I have prepared in the guide. And one key thing you got to do here is replace this with your name. Go ahead and write that. And now we can also initialize this as a Git repository in order for us to create a recipe here to have Yocto build our application and run it on the hardware. We're going to have to provide a Git remote in order for the create recipe tool, which we're going to use to create a recipe from this kind of starter code that we're playing with. So here we go ahead and do Git init. Now we have this empty Git repository initialized here locally. We're going to have to also create the remote on GitHub itself. So we go over to our GitHub, go ahead and create a new repo. And here I'm going to call this Flutter custom. We're going to reflect the name that we chose in on the Linux host. So Flutter custom, leave out the description for now. We can call it public or private. In this case, if you do public, that's fine as long as you're not worried about other people seeing your code. If you do want to do a private repository, you also have to make sure you configure SSH keys. Okay, so we're going to leave everything public here for now. We're going to ignore the license. I'm going to manually end up adding that. And then we go ahead and create. The key thing here that we need is these two remote URLs. And interestingly, we will need both. We're going to need the HTTPS and SSH URLs, and that is because of some quirks of the create recipe script that Flutter provides. My recommendation would just be to add both, because if you don't add the HTTPS URL, you'll still get some kind of error. It's a very quirky tool that I should probably explore a little bit more and potentially contribute back, since it seems to be giving me problems. So if you have any problems, let me know in the comments below, and we can figure out what the best course of action is. But so now that we have these two URLs, I'm going to grab the HTTPS one first, navigate back over to my Linux host. We're going to do get remote add origin, and we're going to provide it the HTTPS URL. We're also going to get remote add origin -SSH, and then we'll use this one to push and pull our code. We can go ahead and add SSH. Now we have our two remotes, essentially the same location but different types of URLs. And again, this goes back to some quirks I encountered working with the create recipe tool from Flutter. This may have improved since I explored it, since I saw some changes having been pushed even during the recording of this video, as you saw. So yeah, just heads up. This may no longer be a thing, but it was at the time that I explored it, and I found that I had to add both. So we're gonna go ahead and just do get add wildcard, and we should see pretty much this whole app directory is added except for these dot files or the dot directories. So now we can go ahead and create a first commit. I'm just gonna do git commit first commit. And we're gonna have to push. Oh, and you know what? This is gonna be on branch master by default. The industry is moving away from that. Let's go ahead and rename that to main. Perfect. And then we're going to push main. Git push origin SSH. Oops. There we go. Yes. And it looks like my SSH keys here on this host are not configured on my GitHub. So I'm going to go off screen and set that up. There's a lot of guides on the internet on how to do this, configuring your SSH keys on GitHub. So go ahead and follow one of those generally available guides, and you should be all right figuring this process out. And with your keys configured in GitHub, now we should have no problems pushing and authenticating. Once we have our code pushed to the remote repository, now we're ready to go ahead and create a recipe from this. In order to do that, we are going to stay in our terminal session here for the workspace automation environment, and we're going to leverage the create recipes Python script provided in the meta layer. Now, I ran into some strange behavior if I use the BSP environment and run this create recipes tool from this directory. I found that it just wouldn't work if I did that. I have to run it from in here with the workspace automation environment sourced. I don't know what's up with that quirk, but we're gonna have to call the create recipes.py from our workspace app Flutter custom. Actually, not from here. We want to be at the root of our workspace, so from here. And we're gonna go ahead and grab the path to our application. So that's gonna be a relative path, and I want to just use my pre-setup code here, so run it from the right place. And the rest of the arguments look like so. Actually, before I do that, you should set the name here so that's properly configured in your recipe. And that is just about it for what you'll have to configure. So now we can push enter. We can see that our recipe here is auto-generated. Let's take a look at that. In order to first make this recipe fully functional, we are going to have to modify it just a bit. There's a syntax issue. I think the create recipes Python script in the Flutter project is just needing some updates. It is open source, so if anyone would like to go ahead and fix that, I think that would be a great opportunity to get involved. This name is just way too much. We're going to shorten that down. We just want Flutter custom to be Flutter custom upon installation. The other thing we're going to have to add is this guy. From here, we are good to go to copy our recipe over to our BSP. Let's go ahead and just copy that over to the root of that BSP and switch tabs now. In order to now enable this recipe that we have, which recall it is right here now, we're going to have to create a meta layer to add it in. And so what we could do is leverage the big layers tool, create layer, give it a path to create it, and we're going to call it just example. I think you can call it anything. And then we're going to add our recipe to that directory. I recommend navigating in there, creating a path such as this, recipes Flutter, and then we'll give it the name of the app, so Flutter Custom, and then we'll create that directory and then copy our recipe, like so. That should be it. And then we're going to copy that to recipes Flutter, Flutter Custom, and we're also going to call this a little bit more nice of a name. So we're going to do Flutter Custom and then underscore. This separates the package name from the package version, and this is going to be, we're just going to call this version 1, and then this is a BB file. So we're just renaming this into something a little more short and sweet. It pretty much is just this end of the file. Go ahead and copy that. Now, if we navigate to Builder, we can bitbake layers, add layer. We can enable that meta layer, and then we can also grab that recipe name and enable the recipe. We go do that by navigating into our conf/local conf, and I'm going to just replace the Flutter samples with Flutter Custom, and we're going to go ahead and rebuild our image. Once that completes, we can find our Qt6 demo image here in the deploy directory. Recall we just built Qt6 demo image and just added the Flutter stuff. So we're going to go ahead and flash this to an SD card. And there we have it. Let's go ahead and boot that up. All right, now that that's booted up, recall that this is more or less the default Qt6 demo image. We've reflashed the SD card, so we'll have to make our Weston ini change again. And now we can go ahead and run our new demo, which is the Flutter Custom application. So it's going to look like this. And it's difficult. It's a little difficult to make it out here on the white screen using my webcam, but there is a button here in the bottom corner. But take my word for it, this looks exactly as it did on the host. I think that will come through a lot better in my recording. This is just kind of getting washed out. And Control-C that application, Qt file will start up again. That's okay. We're going to go ahead and just turn this off, because now we're going to take our custom GUI a step further, and we're going to add a button to it. Back in our workspace automation app Flutter Custom directory, we're going to first remove that main function of our application. That here is provided here by libmain.dart. Go ahead and remove that. We're going to go ahead and populate some code I have prepared off screen here. Like so. What are we doing here? Well, we're first importing this process run shell.dart library. This is going to allow us to kick off some user space commands in our GUI directly. We can see that here. This GPIO set is going to turn on the GPIO, turn it off, and we're going to do that here in this toggle GPIO function. That is going to get called every time we press the elevated button widget, which we've enabled here in our GUI. And there's some other things going on in here, such as the home page extending the stateful widget. I believe that is in order to allow us to track global variables so that we can keep track of the state of that toggle button. Go ahead and study this code further. We are going to use that here, and let's see how it runs on our host. So we should expect that the application will build itself. Maybe I spoke too soon. Recall that we added a new process run library here. In order for that to work, we're going to have to add that to our pubspec.yaml file. So each Flutter application is going to come with a pubspec.yaml file. This is going to describe to Flutter what the application's dependencies are and what versions or minimal versions are going to be supported. We're going to have to add process run to this list. We can do that down here on the dependencies section, right here, like so. And so now this is telling the Flutter build system that, hey, we are using process run, we need at least this version, please use that when building our application. So now I should find that Flutter run, whoops, cross my fingers, Looks like we have a couple lines of red output, which is usually not a good sign, but I believe these are safe to ignore. I'm not familiar with what these are, but our application here is running without issue, it seems. We can go ahead and toggle the button, and as expected, I wouldn't expect the GPIO set or the GPIO D utilities to run properly on my host. I don't even think I have them installed, which this no such file seems to confirm. So that's normal, but at least we can here test how the behavior of the toggle button, and we can see that at least it's trying to call these GPIO set commands. Let's go ahead and get this running on our hardware and see if it works okay. So how do we go ahead and update our recipe to reflect our new application here? Well, first things first, we're going to check git status, and we're going to add the two files we modified. So git add, we're going to add libmain.dart and the pubspec.yaml. Those are the two files we updated, and we're going to go ahead and push those. So we'll have to commit first, give it a message that's descriptive, so toggle blink code, or maybe example. We'll go ahead and git push to origin. We're pushing main, and recall I want my SSH credentials to kick in, so we're going to push the origin SSH, and then now we're going to just confirm the latest commit of our git log here. So this is the most updated snapshot, if you will, of our code. Now we can go ahead and go into our BSP directory, and we're going to go and then enable our latest snapshot of the code by going into our recipe. And we're going to update the source revision to reflect our latest commit. And this is the easiest way to get this recipe to now grab the latest version. Perfect. Now we can just go ahead and very simply rebuild the image again. Once we get that image rebuilt, booted on the hardware, and then we switch over the Weston config to the LVDS display again, then we should be good to go trying out our latest application here. The same command we used before. Recall that we just updated the existing application. A little difficult to see the button on the UI, but it is working. There's Flutter.